All right, let's go.
Number 9. The inside-out planetary system. Rocky, gas, gas, rocky, in that order. Planet formation theory says there is a rule so fundamental it applies to every system astronomers have ever modeled. Rocky planets form close to their star. The intense heat near a newborn star strips away surrounding gas from small planetary cores before it can accumulate. What is left are dense, rocky worlds like Mercury, Venus, Earth, Mars. Further out, where temperatures are cooler, gas can accumulate around forming cores. It piles up, builds massive atmospheres, creates gas giants like Jupiter, Saturn, Uranus, Neptune. Rocky in, gassy out. That is the rule. It is built into every planetary formation model ever constructed. In May 2026, a team of astronomers published findings from ESA's CEOPS satellite on a system called LHS 1903, a small red dwarf star with 4 planets. The inner 3 fit the model, 1 rocky planet, then 2 gaseous planets further out. Normal, expected. Then there was a 4th, orbiting further out than the 2 gas planets. Rocky, dense, an iron silicate world nearly 6 times Earth's mass with the composition of Mercury. A rocky planet sitting where the model says only gas planets should form. The arrangement reads rocky, gas, gas, rocky, in that order. The leading explanation from the research team is that this 4th planet formed late, after its siblings had already consumed most of the disk's gas. It assembled from whatever solid material remained after the inner planets were done forming. A planet formed from the leftover scraps of a system that had already finished forming everything else. The theory has existed for over a decade. LHS 1903 is the first planetary system to provide actual evidence it might happen in practice. Number 8. The hot Jupiter with a companion that should have been destroyed. Hot Jupiters are the most disruptive planets in the solar system. When a gas giant migrates inward from its formation zone beyond the frost line, dragged towards its star by interactions with the disk material around it, it scatters everything in its path. Smaller planets get ejected, dragged into the star, destroyed. The result is always the same. Hot Jupiters are lonely. A hot Jupiter will not have companion planets inside its orbit. The physics of migration is too violent. Whatever was there is gone. In May 2026, a team of MIT published JWST observations of a system called TOI 1130. It has a hot Jupiter, and tucked inside its orbit, closer to the star than the hot Jupiter itself, a mini Neptune, a smaller planet that should not exist, that should have been scattered or destroyed during the hot Jupiter's migration. It is there, in mean motion resonance with the hot Jupiter. Their orbital periods are locked in a ratio. The inner planet completes an orbit every 4 days, the hot Jupiter every 8. They orbit in sync in a 1-to-2 resonance. That resonance is likely what saved it. If the inner planet formed at exactly the right location relative to the migrating giant, it could have been captured into resonance and carried inward alongside it rather than destroyed. A narrow window, an unlikely rescue. One system has shown this is possible. TOI 1130 should not have 2 planets this close together. It does. Number 7. The gas giant orbiting a star too small to have made it. Planet formation requires raw material. The protoplanetary disk around a young star contains the gas and dust from which planets must build themselves. The size of that disk, the amount of material available, scales directly with the mass of the central star. A small star has a small disk. A small disk has less material. Less material means smaller planets. The core accretion model, the standard framework for how gas giants form, requires a rocky core of roughly 10 Earth masses to begin rapidly accreting gas from the surrounding disk. Around a very small star, there simply is not enough material in the disk to build that core before the disk disperses. The prediction is clear. Stars below a certain mass threshold should not host gas giant planets. In June 2025, astronomers announced TOI 6894b, a planet slightly larger than Saturn, orbiting a red dwarf star with just 21% of the Sun's mass, one of the smallest stars ever found hosting a transiting gas giant. According to standard formation models, this planet should not be there. The star was too small to produce a disk massive enough to build a Saturn-sized world. The discovery was confirmed by NASA's tests in the Very Large Telescope. It is real. The planet is there. How it formed is unknown. Disk instability, where the disk gravitationally collapses directly into a planet without the intermediate core building step, has been proposed as a possible pathway that bypasses the mass requirements of core accretion. But this model has its own challenges for objects of Saturn's mass. No formation scenario cleanly explains TOI 6894b. Number 6. The planet orbiting a dead stellar corpse, circling a neutron star that already destroyed everything. When a massive star dies in a core collapse supernova, the explosion is not subtle. It releases more energy in 10 seconds than the sun will emit over its entire 10 billion year lifetime. The blast wave propagates outward at tens of thousands of kilometers per second. It sterilizes the surrounding space completely, burns away any disk material, destroys any existing planets, ends everything in the nearby stellar system. That is what we expected. Then, in 1992, Alexander Wolszczan and Dale Frail published the first confirmed detection of planets outside our solar system. Not around a sun-like star, around a pulsar. PSR 1257 plus 12, a neutron star spinning 161 times per second. 3 planets, orbiting a stellar remnant from a star that had already exploded. The planets survived or formed after a supernova. Neither option makes simple sense. If they survived the explosion, they absorbed a blast of radiation and gravitational disruption that should have sterilized or ejected them. If they formed afterward, they assembled from the debris disk of a supernova explosion, a disk of materials stripped or left behind after the most violent event in stellar evolution in an environment constantly bathed in pulsar radiation. Then, in 2025, JWST discovered PSR J2322-2650b, a planet with a mass comparable to Jupiter, orbiting a different pulsar. The planet has a helium-carbon atmosphere filled with soot clouds. Scientists believe the pressure inside it could compress carbon into diamonds. The gravity from the pulsar is stretching it into a lemon shape. It completes one orbit every 8 hours. University of Chicago astrophysicist Michael Zhang described it directly. The planet orbits a star that is completely bizarre, the mass of the sun but the size of a city. No known theory explains how a planet in this condition could exist here. Number 5. The planet orbiting 2 stars at 90 degrees, not around the binary, perpendicular to it. When a planet forms in a binary system, it forms from the disk of gas and dust surrounding both stars. That disk aligns with the orbital plane of the binary. The planet inherits that alignment. It orbits in the same plane as the 2 stars orbit each other. This is true for every circumbinary planet ever discovered, all 16 of them known before April 2025, all aligned, all coplanar. Theories suggest polar circumbinary planets, planets orbiting at 90 degrees to the binary orbital plane, literally perpendicular to everything else in the system, could exist. Polar gas and debris disks have been observed around binary stars, but no polar planet had been found. In April 2025, a team published evidence in Science Advances for the first polar circumbinary planet. The system is designated 2MASS J151047868-2818174. 2 brown dwarfs, objects too massive to be planets but too small to fuse hydrogen-like stars, orbit each other on an eccentric path. The team measured the apsidal precession of the binary, how the orientation of the binary orbit slowly rotates over time. The precession rate was retrograde, going backward. The only explanation that fits the mathematics is a planet orbiting at approximately 90 degrees to the binary plane, a planet going sideways around 2 stars that orbit each other. Its orbit describes a circle perpendicular to everything else in the system. It passes over the north pole of the binary on one side, under the south pole on the other. Every previous circumbinary planet orbits flat, like a coin spinning around two coins sitting still. This one orbits like a wheel rolling around two coins sitting still. Number 4, the planet that is flying apart with a comet tail. Stars evaporate planets. This was known in theory. Rocky planets orbiting too close to their host star can have their surface rock heated past the point of vaporization. The rock boils. The vapor escapes into space. A stream of material trails behind the planet as it orbits, a disintegrating planet with a tail like a comet. 3 of these had been found before 2025, all around faint stars too dim for detailed follow-up study. The phenomena was confirmed, the physics was understood, but the objects themselves could barely be observed. In February 2025, tests detected BD plus 054868AB, a disintegrating planet orbiting a star 140 light-years away in the constellation Pegasus. For the first time, the host star is bright enough for detailed spectroscopic observations. The first disintegrating planet discovered around a star bright enough for real science. Observations confirmed the signature of solid material streaming away from the planet in a comet-like tail, rock being vaporized by stellar heat, the vapor forming a trailing cloud of debris that dims the starlight when it passes in front of the star. The planet is losing mass continuously. The estimates from the research team place its remaining lifetime at approximately 2 million years, which sounds like a long time. The Earth is 4.5 billion years old. What makes this system scientifically extraordinary is not just the dramatic death it is witnessing. A disintegrating planet gives astronomers access to its interior. The material streaming away from the surface carries spectroscopic fingerprints of the planet's rock composition. Minerals that would normally be buried hundreds of kilometers underground are being vaporized and spread across the planet's orbit for telescopes to read. A planet destroying itself and revealing its secrets as it goes. Number 3, the planet orbiting backwards, retrograde, against the direction of its own star's rotation. Everything in a planetary system should orbit in the same direction. The star rotates, the disk that formed around it also rotated in that direction. Planets that formed from that disk inherited the rotation. All planets in our solar system orbit the sun in the same direction the sun rotates, prograde, counterclockwise as seen from above the ecliptic. A planet orbiting backwards, retrograde, is not supposed to exist. There is no formation mechanism that naturally produces a planet orbiting against the spin of its star and the rest of its system. In August 2025, astronomers confirmed a giant planet doing exactly this, orbiting one star in a close binary system in a retrograde direction, against everything else, going the wrong way. The only plausible explanation is a gravitational interaction called the Kozai leadoff mechanism. Secular gravitational torques from the companion star in the binary can gradually incline a planet's orbit over millions of years. In some configurations, this inclination can reach and exceed 90 degrees. The planet flips. Its orbit becomes retrograde. It is no longer going the wrong way because of anything that happened at formation. It was pulled there, torqued into its current backward orbit by the gravitational influence of a companion star over an extended period. The mathematics of this mechanism are well understood. An actual confirmed retrograde planet in a binary system remained elusive until August 2025. The system provides direct observational evidence that the Kozai leadoff mechanism does this in practice to real planets. Number 2, the planet with a daily weather cycle made of rocks. Most bizarre weather on known worlds involves extreme temperatures or winds. Kelt's 9b's iron vapor clouds, HD 189333b's glass rain. These are atmospheric phenomena on perpetually hot objects. In May 2026, JWST published observations of an exoplanet 700 light-years away that has daily weather. Not the kind driven by water evaporation and condensation, the kind driven by minerals. Every morning on this world, mineral clouds form. Silicate-based particles, silicates, condense out of the atmosphere as the night side of the planet rotates into daytime. Then, during the day, the heat vaporizes them. The clouds dissolve. By nightfall, they form again as temperatures drop. A weather cycle, based on rock, happening every single day on the same planet. The observations came from JWST's thermal emission measurements, tracking how the planet's brightness changed as it orbited and different sides faced Earth. The pattern was unmistakable: morning clouds forming, daytime clearing, evening clouds returning. Earth has a water cycle. This planet has a rock cycle. Number 1. The TOI 1130 resonance pair and what it says about planet formation. The TOI 1130 system deserves a second entry on this list, not just for its impossible configuration, but for what JWST found inside the inner planet's atmosphere. The mini Neptune, sitting closer to the star than the hot Jupiter, the planet that should not have survived migration, was observed by JWST in the most detailed atmospheric characterization ever done on a planet in this orbital situation. What it found rewrote the expected chemistry. The planet has a high mean molecular weight atmosphere, dense, heavy molecules dominating the spectrum. The best fit to the data points to formation beyond the water ice line, the distance from the star beyond which water exists as ice rather than vapor, a distance that sits well outside the planet's current orbit. This planet did not form where it currently orbits. It formed cold and far out, migrated inward, survived the migration of the giant planet next to it, and now sits closer to its star than any planet of its type should theoretically be, with atmospheric chemistry that remembers its birthplace in the cold outer disk. The formation story that JWST's observations imply is more complex than any existing model cleanly predicted. A planet with outer solar system chemistry orbiting in the inner solar system, locked in resonance with a gas giant that should have destroyed it. 9 planetary systems. A rocky planet orbiting further out than the gas giants in its own system. A hot Jupiter with an inner companion it should have destroyed during migration. A gas giant orbiting a star too small to have produced enough disk material to build it. A planet with a diamond-forming carbon atmosphere orbiting a neutron star. A planet going sideways around 2 brown dwarfs at 90 degrees to everything else. A world with daily rock weather. And a survivor orbiting inside a gas giant's radius with atmospheric chemistry from the outer solar system where it was born. These are not fringe detections. They are published, peer-reviewed, confirmed by multiple instruments. Planet formation science builds its models on our solar system. One example, the universe has been producing counterexamples ever since. Subscribe to Cosmic Hives. See you in the next one.